Okay, so for graphing of inverse function, we'll discuss about two functions, which are uh, linear and rational function. Okay, so let's graph the function and its inverse. Okay, for instance, we have here the function is 3x plus 5. So let's identify first the inverse of this function. So let's have the two steps, step number 2 and the step number 3, wherein we interchange the x and y and we solve for y and we replace y by f inverse of x. Okay, so interchange. So that's x equals 3y plus 5. Add both sides by negative 5. So that results to x minus 5 is equal to 3y. And divide both sides by 3. So we have y is equal to x minus 5 over 3. Okay, so therefore the inverse of this function is x minus 5 over 3. Okay, now since we are graphing the inverse function, we need to identify the point of intersection, okay, for this linear function. Okay, so to identify that, we need to equate the two functions. Okay, so in identifying the point of intersection, again, we equate them. Okay, so that's 3x plus 5 is equal to x minus 5 is equal to 3. Okay, the value of x here will be the x coordinate of our point of intersection. And also, since the line of symmetry of the inverse function is y is equal to x, therefore, the value of x coordinate is the same as the value of the y coordinate. Okay, so I mean the value of the y coordinate is the same as the value of the x coordinate. Okay, so now let's solve for the uh, value of x here. So cross multiply, so that's 9x plus 15 is equal to x minus 5. Then combine like terms, so that is 9x minus x is equal to negative 5 minus 15. 8x is equal to negative 20. Divide both sides by 8, so that is negative 20 over 8. Or, if in decimal form, that is negative 2.5. Okay, so therefore, our point of intersection here is negative 2.5 comma negative 2.5. Okay, so remember the line of symmetry, okay, of our inverse function is y is equal to x. Okay, so let's graph that. So in linear function, we need to identify the intercepts. Okay, so let's identify the intercepts to sketch the graph of 3x plus 5 and x minus 5 over 3. Okay, so for the function 3x plus 5, the intercepts are negative 5 thirds comma 0 and 0 comma 5. While for the inverse function, the intercepts are 5 comma 0 and 0 comma negative 5 over 3. Okay, so now let's graph this. Uh, Aside from the manual uh, uh, technique, manual use of paper and pen to graph this, to sketch the graph, you can also use the Desmos. Okay, so we'll use this also later for the rational function. So in this case, we have this one. So negative 2.5 comma negative 2.5 is the point of intersection. Okay, and remember again the line of symmetry is y is equal to x. Okay, so we have here the graphs for the function. The intercepts are 0 comma 5 and negative 5 thirds comma 0. While for the inverse, we have here 5 comma 0 and 0 comma negative 5 over 3. Okay, so we have now the graph of the linear function and its inverse. Another example, we have here the rational function. Okay, so we need to identify the zeros, x-intercept, y-intercept, and its asymptotes. Okay, so later on, I will not use the sign table. Okay, because use the Desmos to graph this. But if you're going to solve this and to show the complete solution, of course, you need to have the sign table, okay, for the inverse function, okay, and also for the function itself. So now we solved it earlier. The function x plus 1 over x plus 2, the inverse is 1 minus 2x over x minus 1. Okay, so let's identify the zeros here. So for the function, okay, we let y be equal to 0. So in this case, if y is equal to 0, then x is equal to -1. Okay, and also since it's our 0, we can have our x-intercept as -1, 0. And then for the y-intercept, we let x be equal to 0. So 0 plus 1 over 0 plus 2. So that's 1 half. 0, 1 half. And then for the vertical asymptote, again, look at the denominator. So x plus 2 equate it to 0. So the vertical asymptote now here is x is equal to -2. Well, for the horizontal asymptote, so as you can see here, the degree is equal. Okay, the degree of the numerator and the degree of the denominator are equal. So therefore, we get the numerical coefficient, so 1 over 1, so y is equal to 1. Okay? While in the inverse function, identifying the 0, we let y be equal to 0 again. So 1 minus 2x is equal to 0. So that is x equals 1 half. Okay, 1 minus 2x is equal to 0 and x is equal to 1 half. And then for the x-intercept, of course, that's 1 half, 0. And then y-intercept, we let x be equal to 0. So 1 over -1. So that's -1. So 0, -1. While for the vertical asymptote, again, look at the denominator, equate it to 0. So x minus 1 is equal to 0. So x equals 1. And then for the horizontal asymptote, again, same degree. So all we need to do is to get the numerical coefficient of x. So we have here -2 and then 1. So -2 divided by 1. So that's -2. Y is equal to -2. Okay, notice that the x-intercept and the y-intercept, they are just the inverse. Okay, so as you can see, the x-intercept of the function -1, 0, while for the inverse, that's 0, -1, the y-intercept. Same with the y-intercept of the function 0, 1 half. It is the x-intercept of the inverse 1 half, 0. So as with the asymptotes, observe the asymptote. So vertical asymptote of the function x equals -2, while in the inverse, that's the horizontal asymptote, which is y is equal to -2. Okay, so as with the horizontal asymptote of the function and the vertical asymptote of the inverse function. Okay, so if we graph this again, you can use the sign table to graph the two functions. Okay, and also remember the line of symmetry here is y is equal to x. Okay, so now the graph of the rational function and its inverse is this one. Okay, so we have now here the intercepts. Also, I forgot to include here the um, asymptotes. So don't forget, whenever you are graphing this, include also your vertical and horizontal asymptotes. Okay? So whenever you graph an inverse function, it's just twice the effort that you gave whenever you are graphing a rational function. Okay, so in this case, look at this one. Okay, so I will not expound this since we discussed earlier about the rational function. And then another example, 2x minus 5 over x plus 4. Again, we have now the inverse here for x plus 5 over 2 minus x. Okay, so you can solve again using step 2 and step number 3. You interchange x and y, and then you solve for y, and then replace y by f inverse of x. Okay, now let's identify the zero, okay, of the function. So again, we let y be equal to 0. So that is 2x minus 5 is equal to 0. So that is 5 halves. Okay. So as with the x-intercept. Okay. And then for the inverse, we let y again be equal to 0. So that's 4x plus 5 is equal to 0. And x is equal to negative 5 over 4. Okay. So again, zeros and intercepts are the same. Okay, they are the same. And then, while for the y-intercept here, if we're going to solve this, we let x be equal to 0. So that's negative 5 over 4. So y-intercept of the function is 0, comma negative 5 over 4. While in the inverse function, we let x be equal to 0. So that's 5 over 2. So that's 5 halves. Okay, correction. It should be 5 halves. 0, comma 5 halves. Okay. And then for the vertical asymptote, again, equate it to 0, the denominator. So x plus 4 is equal to 0. So x is equal to negative 4. While the inverse, we equate it to 0. So 2 minus x is equal to 0. So x equals 2. Well, the horizontal asymptote, again, the degree of the numerator is the same as the degree of the denominator. So therefore here, let's get the numerical coefficient. So 2 over 1. So y is equal to 2. While here we have 4 and then negative 1. So 4 divided by negative 1. So that's negative 4. Okay. And notice, if you recall our strategy when we are identifying the domain and range, given that we have this case, all we need to exempt are the asymptotes, the vertical and horizontal asymptotes. For the function, we exclude the value of x, which is negative 4. All real numbers except negative 4. And then for the horizontal asymptote, all real numbers except 2. Okay, for the inverse function, we have now here, we exempt the value of the vertical asymptote, which is 2. So all real numbers except 2. Then just like what I've said earlier, for the range of the function, all real numbers except 2. Okay? Since the horizontal asymptote here is 2. While here, y is equal to negative 4, so all real numbers except negative 4. Okay? And then for you to graph this, again, you need to use the sign table. Okay? Don't forget to use the sign table here. Then now, here's the graph. Okay, so notice we have here the intercepts. Okay, we don't forget the line of symmetry here. And also, don't forget the asymptotes. Okay, since the graph is already done here, I cannot put the asymptotes there. Okay, so for your reference, go back to our lesson in rational function, graphing rational function.